Hello again. Now we are doing the same type of situations, the same type of problems that we are doing before, but now it's just a little twist. The problem tells you two parts. First, replace the force system, I mean all the forces, by only an equivalent resultant force and a moment at the point A. Whenever you see that, what the problem is asking you to do is just calculate the resultant force and the resultant moment at point A. Nothing else. So let's do that. If I first calculate the resultant force, what do I need to do? Find the resultant in X, find the resultant in Y. So the resultant force in X will be, for this force here, first of all, what is this force? This force has these two components, this component and that component. This component will be 260 multiplied by 4 divided by, multiplied by 12 horizontal divided by 13. So the X component will be 12 over 13 multiplied by 260. This other force has this horizontal component here, and that will be 300 cosine 45. And this other force has this component in X, and that will be 250 sine 30 minus, because it's going, assuming that you are doing this. Now this force goes to the left, that will be negative 250 sine 30. And that will be 12 divided by 13 multiplied by 260 plus 300 cosine 45 close parenthesis minus 250 sine 30 close parenthesis equal 327.13 pounds. Now we do the same thing in the y direction. Summation of forces in y equals this component, this force, or this component of the force will be 5 divided by 13 multiplied by 260. It's always the parallel with the parallel. 5 divided by 13 multiplied by 260. Now this other component will be 300. Now this is positive because it goes up, but this is negative. It's going to be negative 300 sine 45. And this other component is negative as well because it goes down, negative 250 cosine, because it's adjacent, cosine 30 degrees. And that will be, I don't know, times 260 minus 300 sine 45 close parenthesis minus 250 cosine 30 close parenthesis, enter, negative 328.64 pounds. Now, what do we need? We have something like this. Look, the resultant force in X, the resultant force in Y. That's it. Meaning, this value here is 327.13 and this is 328.64. And if I'm looking for this angle, that angle will be inverse tangent of, don't use the sign because I'm looking geometric values here now, negative tangent of, this is not the direction, okay? This is just this angle. If I want the direction, remember I have to go all the way from the positive x-axis, but I'm not calculating direction in this moment. I'm calculating just that angle over there. So basically that will be 328.64 divided by 327.13. I don't know why I'm closing because there's nothing to close. And then that, and then there's inverse tangent of that, and I get 45.13 degrees. 45.13 degrees. That's the angle. Okay, now, what does that tell you? That is telling you that basically, at the point A, it has to exist a force of certain value. I don't know what is the value, but we're going to calculate it now. And the angle here will be 45.13 degrees. What is the magnitude of the force? Square root of 327.13 squared plus 328.64 squared. So that will be 327.13 squared plus 328.64 squared, and then square root of that, 463.70 pounds. Okay, good. That's the resultant force, 467.70 pounds. That's the force, but now we need the moment. So we need to check all the moments that are produced with respect to the point A. How do we do that? Basically, it's going to be horizontal force. What is the value for this force? Let's say summation of moments at A. And let's say this summation of moments at A is going to come in this way as positive. That will be, let's start with this force. Horizontal force, this force. That force, we said it was 12 divided by 13 multiplied by 260. That is a force, this force, multiplied by this distance, because that's the horizontal distance between the line that passes from point A and the vertical distance to the horizontal component, meaning 4 inches times 4. Direction, put your finger, apply the force, rotation, this way. Good. That means, according to this convention, that will be negative. Let's keep going. Now, this component is this component. What is the value for that component? 5 divided by 13 multiplied by 260. 260, 5 divided by 13. That's the value of the force. And the distance from here to A is given as 30 inches. Remember, vertical force or component, horizontal distance. And put your finger, apply the force, rotation, counterclockwise. We are considering for this problem counterclockwise as positive, positive. Let's keep going. Now we have this one. What is the value of the horizontal component? Horizontal component, this one. That value is 300 cosine 45, and the distance is, force is horizontal, vertical distance 12 inches. Put your finger, apply the force in that direction. What is going to happen? It's going to happen counterclockwise, and counterclockwise positive. This component is this component, which will be what? It will be 300 multiplied by sine or cosine is the same, but I just want to keep this as the angle, sine 45. And that force is vertical, so the distance must be horizontal between this point and the point A. This is the distance, which is provided as 30 inches. And last but not least, then we have this force. We have the horizontal component, which is this one. The horizontal component force will be 250 times sine of 30, and the distance has to be vertical between that point and the point A. Now that distance will be, look, the force is applied here, so that will be 3 plus 16 plus 12. That means 12 plus 16, 28 plus 3, 31. 31. And now we have the vertical force, which is 250 cosine 30. I didn't study the sine, but it's okay. We're going to study the sine of both now. Cosine 30 multiplied by the horizontal distance from here to the point A, which is from here to here. We don't have that. But we have the total, which is 30, and we have this, which is 10. So that means that the distance from here to here will be 20. Now, this force, with respect to the point A, clockwise, meaning negative. This force, wait a second. I said this force, right? This force is this one, negative. And this force is also negative. Both are negative. Okay, good. And now we just have to solve this mess and see what value do we get here. Negative 260 times 12 divided by 13 multiplied by 4 plus 260 times 5 divided by 13 multiplied by 30. What is this I? 30 inches, right? Inches. I don't need inches here. So times 30. First one, I hope that I put a negative. I don't remember. Yes, I put a negative. Okay. Plus 300 cosine 45 close parentheses times 12. And I didn't put the sign for this one. Oh, smart, smart, smart. Which one was this one? This one was this one. Negative. This one. Negative. Minus 300 sine 45 times 30 minus 250 sine 30 close parentheses times 31 minus 250 cosine 30 close parentheses times 20. I don't know if I mess up here. I might have messed up here. I don't think so, but and that will be 9,000 negative 9,983.5 pounds per inch. That will be the moment. So that means that we assume counterclockwise positive, we get negative. That means this is clockwise. So what is the result? The result is that that system, that entire system, could be converted into force here, force 67.70 pounds, and the angle here will be 45.13. That will be the resultant force and the application. This is the wall, okay? And also a clockwise moment in this direction. This is the point A of 9,983.5 pounds per inch. That will be the solution for the first part. Now the second part is asking, I don't want that. I want that only one force that acts along the line AB. But when I place that force along the line AB, it has to produce the same effect as everything combined. In other words, this is what I have right now. And the problem is telling you, no, I don't want that. What I want is that you place that force, the resultant force. You cannot change the value of the resultant force. That's the resultant force. Somewhere along the line AB, and by me placing that force over the line AB, that should produce the same moment, which is clockwise, by the way, and I put it counterclockwise here. I don't know why you don't correct me. Remember, everything that I record is live, so if it's live, it's gonna be bloopers, are gonna be bloopers also, but clockwise. This is clockwise. And when I draw it before, it was counterclockwise, so clockwise. So when I put that force over there, this force placed on that direction should produce the same moment as that. This force with this angle that we calculated, the angle was 45.13 at a distance d from this line, has to produce that moment. Now remember, that force has two components. Component, horizontal component, which is this one, and that value is 327.13, and the vertical component was 328.64. So basically, when I do that, this force, when I put here my point A, right, and I apply these forces in this direction, this force times this distance should provide that moment. Now that moment is what? Is negative. That moment is minus 9,983.5. Has to be equal to this component passes through the point, so it's not producing any moment. So it has to be equal to that component, 327.13, multiplied by this distance d. And then you solve for the unknown, which is d, and that gives you that value divided by 327.13, and pay attention, negative 30.52 inches, negative 32.52 inches. So what the problem was asking you is replace the force system by an equivalent force acting along the line AB. Guess what? It's not possible, because the problem is telling you no. The only way that I can place or produce this force like that is if this force is located above the line AB. So somewhere above this. Look, this force, this component is going to produce a positive moment, going positive moment. So the only possibility is the resultant force to be somewhere here in the air, which I don't know where is that point, somewhere here, and this distance will be 30.52 inches. That will be the solution for the second part. So my resultant force must be placed, if you will, following the line AB, but above, somewhere here, which physically is impossible, but that's the numerical solution, unless I just weld something here and put it there on the top and then put the force somewhere there. That's the only possibility for that to happen. Check this problem several times and keep learning, guys. Thank you for watching.